In this video, I'm going to show you how to determine whether or not you have a function. So before we begin, we should ask, what is a function? Well, a function is a correspondence between a set called the domain and a set called the range. Let's say we have a set, we'll call it the domain, and we'll have a set, call it the range. So this is your domain, and the domain is a set of a function's inputs, so it's the x values, and the range is the set of a function's outputs, which is the y values. So let's say we have a few points in the domain and a few points in the range. So in the domain we can say this is 1, 2, and 3, and the range we can say this is a, b, and c. So as I had just mentioned, a function is a correspondence between both the domain and the range, but the definition of a function states that each member of the domain corresponds to exactly one member of the range. So we can say, for example, that 1 can map to A, 2 can map to B, 3 can map to C. It doesn't necessarily have to go in this order, just as long as each member of the domain maps to only one member of the range. So let's say we had another set for the domain and another set for the range, or let's say we had 2 points here and 3 points here, and let's say this here is 1 and 2, and this here is A, B, and C. If 1 mapped to A, 2 mapped to C, but 1 also mapped to B, this here is not a function because one of the members in the domain, 1, maps to more than one of the members in the range, A and B. But this one up here, of course, is a function. Let's say you were given a question, determine whether the relation is a function, and give its domain and range. So to better visualize what's going on here, we can start with a diagram. So we can draw all the members of the domain on the left and all the members of the range on the right, and then map them. So we have A, so the first coordinate is your domain. So we have A, B, and C for a domain, and range is the second coordinate, which is W, Y, and Z. So W, Y, and Z. So in the first pair of coordinates, A maps to W, second, B maps to Y, and C maps to Z. So, by the definition of the function, where each member of the domain corresponds to exactly one member of the range, this is a function. Is a function. Because A maps to W, B maps to Y, C maps to Z. A doesn't map to both W and Y, then it wouldn't be a function. But since every member in the domain only maps to one member in the range, we call it a function. And to give the domain, it's the set A, B, C. And to give the range, that is the set, the curly braces, W, Y, Z. So we'll do another example. First, we'll start out by drawing a diagram. So we'll put all the members of the domain on the left and all the members of the range on the right. So the domain is all of the first coordinates. So we have -3, 1. You don't have to write 1 more than once if it occurs more than once. So we have 5 and we have 9. And then the range is the second coordinates. So 2, 4, 6, 6 again, and 8. So we have 2, 4, 6, and 8. So in our first pair, we have -3 maps to 2, 1 maps to 4, 1 also maps to 6, 5 maps to 6, 9 maps to 8. So, because 1 maps to both 4 and 6, this is not a function, because the definition of a function says that each member of the domain maps to exactly one member of the range. In this case, it maps to 2, so this is not a function. And the domain is the set -3, 1, 5, 9. And the range is the set 2, 4, 6, and 8. So for a third problem, we will write the same thing again. So we'll write all the members of the domain on the left, all of the members of the range on the right. So domain is the first coordinate, input values. So we have -6, -2, and 2. And our range is the output values. So second coordinate, we have 36 and 4. So -6 maps to 36, -2 maps to 4, and 2 maps to 4. So since each member in the domain maps to exactly one member in the range, this is a function. And the domain is the set -6, -2, 2, so the first coordinate. And the range is the set 36, 4, so the second coordinate. And you don't need to write 4 twice. If it occurs twice, it's in the range in both situations, so you only write it once. So in our fourth example, we'll repeat the same process. So we'll write all of the elements in the domain on the left, all the elements in the range on the right. So the domain is the first coordinate. So we have -7, -2, and 0. And the range is our second coordinate, so 3, 1, 4, 7. So our first pair says that -7 maps to 3, -2 maps to 1, -2 also maps to 4, and 0 maps to 7. So since -2 maps to both 1 and 4, that breaks the definition of a function, because the definition of a function says that each member of the domain maps to only one member in the range. So not a function. So the domain is the set -7, -2, 0. And the range is the set 3, 1, 4, 7. So in our fifth example, we'll repeat the same process. Domain on the left, range on the right. So 2, 3, and 4 is our domain. 2, 3, 4. And our range is the second coordinate. So 10, 15, 20. So 2 maps to 10, 3 maps to 15, and 4 maps to 20. So since each member of our domain maps to exactly one member of the range, this is a function. Is a function. Okay. And our domain is a set 2, 3, 4. And range is the set 10, 15, 20. So for our last example, write the domain and the range on the left and the right side. And our domain, we know, is our first coordinate. So we have M. We have it twice, but we only need to write it once. And we have N, R, and S. And our range is the second coordinate. So we have A, B, C, and D, and C is repeated, but we don't need to write it again. So M maps to A, M also maps to B, N maps to C, R maps to D, and S maps to C. So this is not a function because M maps to both A and B. So not a function. For this to be a function, each member of the domain can only map to one member of the range. So the domain is M, N, R, S. And the range is A, B, C, and D. And that is all. I really hope you learned something. Thank you so much for watching this video. Please like it and subscribe for more content. Bye.